Welcome to ScaleUp University. Welcome to the course on building applications with AI agents. So this is the lecture 17 of module 1 and this is the last lecture of module 1. So this is summary and conceptual framework. So let us look at the lecture overview. So this is the last lecture of module 1. So what we will be looking at this lecture. So module 1, it is about foundations of agent thinking. So all the lectures of module 1, it helped you in building the foundations. Like when you will be building agentic AI application, it will be a complete new mindset because agentic AI application is very different from traditional applications which we have been developing for decades. So there is a need for shift in the mindset, and this module will help you in building foundations of agent thinking. So this module was about that. This module 1 of this course, it was not about tools because in this module, in any of the lectures, we did not discuss in details about the tools. This module was not about code. We haven't discussed even a single line of code. And this module was not about frameworks. Rather, this module was about thinking correctly about agents. And that is very important because now we are shifting from building traditional applications to building agentic AI applications. And it's a very big transition. And it needs a shift in the mindset, a shift in the thinking. And this lecture or this module 1 of this course, it was all about foundations of agentic thinking. It was about thinking correctly about agents. Because before building anything, we should have conceptual clarity. That is very important. Architectural maturity, realistic expectations, and strategic vision. So before building anything, we must have conceptual clarity, architectural maturity, realistic expectation, and strategic vision. And this module 1 of this course, it certainly gave you the conceptual clarity wherein you got a very good understanding about agents, architectural maturity, realistic expectation, and strategic vision. And in this particular lecture, it will be like a revision of module 1. This lecture will be a revision of module 1 wherein we will integrate all the important concepts which we have discussed in this module 1. So that's why this lecture is summary and conceptual framework. If we look at the exact topics that we will cover in this lecture, we will talk about key takeaways from introduction to agents, the mental model of agent systems, the agent loop, where module 1 fits in the course. So all these topics we will discuss in this lecture itself. So this is the module 1, introduction to agents, lecture 17, summary and conceptual framework. So this is the last lecture of this module. And we are starting this like the first topic of this lecture, that is key takeaways from introduction to agents. Key takeaways from this module. So in this module, we discussed in some very good detail why AI agents they matter today. Like why AI agents are so popular, so important. We learned static automation is no longer sufficient. See, static automation is all about rigid rules, wherein we have some fixed workflows, fixed rules. Now we saw that real world environment, it is highly uncertain. Real world environments are dynamic in nature. So this rigid workflows, they brittle, they get shattered. So we need softwares which can adapt and not just execute. So for the dynamic real world, we need softwares that can handle edge cases, that can adapt based on the real world scenarios. So we want something wherein we can get rid of that rigid rules. We want intelligence wherein code can on its own solve a problem without us telling it how to solve a problem. So that intelligence we need, that's the need of the hour. And fortunately, we have agents with us. So with AI agents, they're equipped with intelligence. The shift from rule-based automation to autonomous goal-driven systems. So AI agents, they are autonomous systems, like they can solve a problem on their own, and they are goal-driven systems. And the best part about agent systems is they are adaptable and they are perfect fit for real-world dynamic environments. Then we discussed what an autonomous agent is. So we discussed the loop, the feedback loop, wherein we saw that, okay, AI agent, if we talk about it, perceives the environment, that's a perception. Then it has goal in mind. It knows what goal needs to be accomplished. So it does the planning. So it make decisions, like it makes a set of action plans. It will execute that. It will take actions. Then it will reflect whether the outcomes of those actions. It will assess that. It will adapt. It will revise, re-strategize, and it will keep on doing it until the goal is achieved. And here the agent, it will be continuously acting under uncertainty. It will be operating under uncertainty. So autonomous agent, and it will act autonomously, like it can act on its own. That's why it is autonomous. So an autonomous AI agent, it can perceive the input, it can make decisions, it can take actions, and it will keep on doing it until the goal is achieved. And it operates under uncertainty. So it is not a chatbot. So autonomous agent is not a chatbot. So chatbot is very passive, wherein chatbot cannot execute actions. It can only reply. Autonomous AI agent is very different from simple ML model. See, simple ML, machine learning model, they are very passive in nature, wherein they can just respond. They cannot act. It is very different from a script. Script means rigid, fixed rules, fixed set of instructions. Rather, for agent, for AI agent, they decide what to do. Rather than we telling it what to do, it will decide what to do. And it is not a workflow engine. Wherein workflow, it decides dynamically during the runtime. And here, one more very important thing we discussed. See, autonomy does not mean no supervision. In agentic AI applications, like for autonomous agents, human supervision is always there. So autonomous does not mean no supervision. Rather, it means autonomy means decision making without step-by-step instructions. So here, the autonomous AI agent, it has the power to choose. It can choose the plan. It can make the plan on its own. It can decide the set of actions. But it is always under the human supervision, wherein if it drifts away from the goal, human can be introduced in the loop, human in the loop. So in module 1, we also looked into agents versus traditional machine learning systems, wherein we saw that traditional machine learning systems, they can make predictions based on the input, they can perform inference, and they operate in static mode. But on the other hand, if I talk about agents, they are very different from traditional machine learning systems, wherein agents can plan, they can execute, they can monitor, they can adapt, and they will keep on iterating this until the goal is achieved. So agent is like a process, and traditional machine learning system is like a input output. Like I gave an input, it instantly gave me an output. So that's it, input output. So machine learning systems, it can make certain predictions, it can perform inference, and they operate in static mode. But agent, they are dynamic in that sense that they will keep on working until the goal is achieved, and they will keep on changing their strategies. Like initially they will make a plan, they will execute, and they will monitor. If they will feel like the outcomes are not satisfactory, they can revise the plan. They'll keep on doing it, this iteration. So we can say that one very important insight, machine learning is a component. Like it will take an input, it will generate an output. But agents, they are systems. Like they will keep on running asynchronously. They'll keep on working until the goal is achieved. So agents are systems and machine learning is a component. Then in module 1, we looked into foundation models as the backbone of agentic AI application. Foundation models as the backbone. So we saw that, okay, foundation model, if I talk about the large language models, they are the foundation models. So we saw that, okay, foundation models, large language models, they are very powerful, wherein they provide reasoning. They can interpret the natural language. They can decompose tasks. They can play a role in planning. Planning is all about, okay, whatever end goal I have to achieve, I decompose, I make some action plan. I decide set of actions which needs to be taken in order to achieve the main goal. So that is decomposing the task in order to achieve the main goal. And foundation, like LLM models, foundation models, they can generate structured outputs. They can understand the natural language, and they provide reasoning framework. So foundation model is the backbone of agentic AI applications, wherein the intelligence in agentic AI application is because of the foundation model. Foundation model is like the brain. Now we also saw that foundation models, they have some limitations. So a foundation model is not an agent. Agent is different from foundation model. Because see, if we talk about foundation model, they don't have any goal. Because foundation model is like very passive in that sense that, okay, whatever input you will give, it will give the output. That's it. No goal, no memory. It will not remember any interaction also. No execution layer. It will never act. It will just respond, and no monitoring loop. So since all these things are not there, so foundation model is not an agent. Agent is something different. Agent will have a goal. It will make use of the memory. It will store the state. It will have execution layer wherein it can act. It will monitor the outcomes of its action. It will strategize, revise, all that it will do. So agents, if we talk about agents, they wrap models with objectives, tools, orchestration, and guardrails. Then in this module 1 of the course, we looked into core capabilities of modern agents. So we saw that agents are very powerful. If we talk about the capabilities of modern agents, we saw that they can maintain context. They can understand natural language. That's very powerful. They can plan sequence of actions. They can make use of tools. They can adapt to changes. So this is a very important feature. So agents in the real time, any change, any uncertain situation, agents can handle it. They can handle multi-step workflows. They can recover from errors, and they can intelligently recover from errors on their own, and they can incorporate feedbacks, and these feedbacks will help them in aligning with the goal, or these feedbacks will adjust their behavior so that they can work even more efficiently to achieve the goal. So agents are not about responses but about outcomes. Agents, they manage outcomes, not responses. Then in module 1, we looked into why agents became viable now. Because see, this the concept of agents, it was very old. Like in 1980s also we had concept of intelligent agents, but at that time they were not feasible. But now agents are feasible. They are viable. Why is it so? Because of advances in large language models. Because large language models, like they act like the brain of the agent. Now we have something like large language models which can understand natural language, which can reason, which can plan, which can generate structured outputs. So this enabled agents, tool calling capabilities, which acts like the hands of the agents, improved infrastructure, wherein now we live in the era of cloud computing, elastic compute, wherein we can scale the cloud scalability, the reach. As per the need, we can keep on scaling, adding up more and more resources, more and more compute. Efficient inference. Now, because of the infrastructure, improved infrastructure and advanced LLMs, the inference is very fast. Efficient inference we are able to achieve. And reinforcement learning principles, the experience. Now, the LLMs, because of the power of RAG or the context, with context, we can upgrade the knowledge of LLM. Because see, LLM, when it was made, it was trained on terabytes of data. So it has static knowledge. Whatever training you did, it has static knowledge for that LLM. But now, with the power of context, like when you are giving the prompt, you can add some very interesting context. So the LLM, while generating the response, it will take into consideration that context also. That context will add the knowledge. So whenever you want to train the LLM on the fly, you can do it via context. So we call it the experience. So reinforcement learning principles, with the reinforcement learning principles, LLMs, they can evolve, they can upgrade their knowledge without them without retraining them. So these are like some very interesting capabilities which made agents viable. So the key takeaway which we saw was agents, they did not suddenly appear, because agents was like a very old concept. They became viable due to converging advancements. Now, what is the next big driver? The next big driver might be quantum computing, because now one very big challenge in front of us is the GPUs, the compute. Because now, in order to make a LLM, we need like good GPUs, compute power. So, quantum computing, it might be like a very big thing, wherein the compute power, that might like explode. Like small miniature chips can have very high computing powers, because quantum computing will be totally different, because normal computing is in binary state, flip flop, 1010. This quantum computing, it will take into consideration many states. That's the idea. Okay, then we also looked into real world use cases. So some real world use cases of agents, wherein we saw that okay, agents, they can play a role in customer support, personal assistants, they can act like, they can play a role in legal systems, marketing, analytics, and enterprise automation. So agents, they are powerful where task, they are multi-step, context matters, decision affects the outcome, adaptation is required. So wherever adaptation is required, so this is very important, because see, the idea is that there might be certain scenarios where where we might not be needing agents at all. So when we should go for agent is when adaptation is required, because there are many scenarios wherein the brittle logic might work, wherein the fixed workflows, the hard coded logic might work. And in those scenarios where the brittle logic might work, the hard coded, the rigid workflows might work, the hard coded set of instructions might work, there we should not go for agents. Agents will come into picture only when we have to deal with uncertainty. When the system is exposed to the uncertainty, to the dynamic world, where adaptation is required, agent will come into the picture. So that's a very important insight we looked into. And when tasks are multi-step, so all these are secondary thing. First, okay, adaptation is required, go for agents. Then try to break the goal into subtasks. That is what agent is good in doing. Reinforcement learning, like context. So all that we can consider. Okay, managing expectations. Okay, now it's very important that, okay, agent, they are powerful, but they are not magical. This is like a very clear boundaries we have to draw. Agents are powerful, but they are not magical, because expectation is very important. Because when artificial intelligence, it was evolving, we had like a very high expectations from it, and we saw something called as AI winter. For more than 3 4 decades, we did not saw any breakthrough in AI, so any significant breakthrough. So similarly, agents, we should be very clear with expectations. We should not over rely, over trust the agents, because they can hallucinate, they can make mistakes. So the quality or the performance of the agent, it depends on the model quality, because agent is not something magical. The performance of agent will depend on the model quality, it will depend on the data quality, it will depend on the orchestration quality, it will depend on the monitoring systems, and it will depend on the human oversight. So it's not just about LLM. Let us suppose you are having like a very advanced LLM. That is not sufficient. That is important. With LLM, reasoning capability will be very good. That's very important. But the performance of agent, the quality of agent will depend on several other factors as well, like the model quality, data quality, orchestration quality, monitoring systems, and human oversight. So we should not over automate. So over automation is very dangerous. And alignment is critical, alignment with the goal. Then we also looked into designing for change, wherein we saw that, okay, agentic AI application we are making. So when we are designing the agentic AI application, we have to keep several things in mind, like the we should follow modular approach, wherein if we are building agents, we should make it modular, wherein every module will act like a component responsible. It will have a fixed responsibility. So we call it separation of concerns. Every module, every component will have a its own responsibility. Like perception module will be responsible for input signals. Planning module of the agent will be responsible for the planning. Execution module of the agent will be responsible for executing the strategy, like that. Then we also looked into the scalability aspect, wherein let us suppose we designed an agent. Now it is handling a traffic of 10 users. Now we want it to handle traffic of thousands of users or millions of users. Then we have to make it scalable, resilient. So we have to make agentic AI applications resilient. Resilience means we will welcome the faults. We will not prevent the fault. Rather, we will design systems which can handle the fault, which can tolerate the fault. So fault tolerance and future proof. Future proof means, see, AI is very dynamic. AI is evolving. So whatever agentic AI application we are making, it should be alive. Like it should make sense for years. It should not happen that, okay, any new advancement in AI and it is blowing away. It should not happen like that. So that is future proof. So this very important discussion we made, wherein we talked about agent design, like agent AI application design. We have to keep in mind the modular architecture, the scalability, the resilience, and the future proof. And agent design, the agentic AI application, we should start with a very small scope, and we should keep on evolving it. So we call it continuously improving. So this is also very interesting and important insight which we saw in this module, that whenever you are planning to build agents, don't have very big goal in mind. Rather, try to accomplish small workflows, and then you can build something big. You should iterative design, we call it. We should keep on evolving, iterative design. So very good insight. We saw that static agents, they degrade. Static agents are those which will not improve with time, which will not learn also, which will not adapt, and which are not future proof. And adaptive agents are those which are future proof, which will continuously improve, and adaptive agents, they will endure. Then in this module, we also discussed multi-agent thinking, wherein we shifted our focus from single agent architecture to multi-agent system, wherein we talked about multiple agents. They are working together. They're collaborating. They're coordinating with each other. And we also saw that in multi-agent systems, orchestration will be very important, and orchestration should be system level. System level orchestration. System level orchestration means that we should have a dedicated agent which will orchestrate, which will have a bigger goal, and which will decide the subtask, and which will assign that task to other agents. So that we call it like the system level orchestrator, wherein one or a small set of agents, they will be orchestrating the system. And we also saw collective intelligence, because in with multi-agent systems we achieve collective intelligence, wherein every agent is specialized in a certain domain. Every agent has got a certain capability. They are working together. They are solving small problems, and those problems are aligned towards solving a very big problem. So that's the idea. That's the multi-agent thing. So we saw that, okay, when one agent is not enough, we should go for distributed problem solving. So multi-agent systems, they increase capability and also complexity, because multi-agent system, definitely it will increase capability, because we will be having individual agents, many agents, they are working together. Every agent will be having their own capability, and complexity will also be increased, because now the big challenge will be the coordination among the agents, because instead of managing a single agent, we have to manage multiple agents. So complexity will be increased. The mental model of agent systems. Okay. So if we look at the difference between agents, model and system. So if we talk about a model, so model is like the foundation model. It is the large language model. Now we are already aware that, okay, model, it has got intelligence with it. It can predict, it can generate natural language responses, it can classify, it can transform text. So a model predicts, generates, classifies, and transforms text. So a model, it is probabilistic in nature, wherein it can handle uncertain situations of real world, and it is stateless. Like model, it does not remember the interactions. It's like request and response. That's it. Session closed. Then we also saw agent. So if we talk about an agent, so agent follows a loop. So agent, what it does is that it uses a model, it has a goal, it does the planning, select actions, it will execute the actions, it will call tools, execute the actions, it will maintain the context, whatever the outcomes it got, it will store it somewhere, we call it the context. It will monitor the progress, it will assess the outcomes, it will adapt, it will re-strategize, replan, it will keep on doing it until the goal is achieved. And in this process, it will make use of the model. So an agent, it operates in a loop. An agent, it operates in a loop. Now we'll discuss agent system. If we talk about an agent system, it includes infrastructure. It includes memory stores. Okay, so this is very interesting. So in an agent system, we will be having model. We can have multiple models. We can have multiple agents. Along with that, we will be having infrastructure, memory stores, orchestration. Agent system will be having orchestration. It will be having monitoring. It will be having human oversight. It will also include security. And that is what we will be doing. Like whatever agentic AI application you will be making, it will be an agent system, wherein that agentic AI application, it will be making use of models. It will be having, it can have a single agent. It can have multiple agents. Those agents will be making use of models. Along with that, the agentic application, it will be having infrastructure, memory stores, orchestration, monitoring, human oversight, and security. So an agent system is a production software. It is a production software. The agent loop. Okay, so this is something, so very important key takeaway from this module, because when we think about agents, we have to think about the loop. So every agent will have a goal. To achieve the goal, it will perceive the input. To achieve the goal, it will perceive the input signals. It will interpret the context, and then it will make a plan. It will plan actions. It will make a action plan wherein it will decide set of actions. The order also it will decide, and then it will execute that plan. So this is the fourth, execute tools. It will execute the tools. Then it will observe faults, observe results, outcomes. So when it will execute the strategy, plan, action plan, it will get some outcomes. It will observe it, and based on that, it will adjust the strategy, and it will keep on doing it. The agent will keep on doing it until the goal is achieved, and it will adjust the strategy in such a way that it will go more and more closer towards the goal. So agentic AI application is all about this. Agent is all about this. So whether you are dealing with one agent or multiple agents, every agent is doing this. They are working towards accomplishing goal, and this is how they accomplish the goal. So this is the most important key takeaway from this module. This will help you in building agentic AI application. Okay, where module 1 fits in the course. So see, basically module 1, it was like an introductory module. It was like the foundation of agent thinking. So it was able to answer some very important questions like what is an agent, why now, so definition of agent, the timing, where use, the applications of agent, the limitations of agent also we saw, like managing expectations, constraints, how to think, the mindset. This module, it built vocabulary. You came across many interesting terms, mental clarity, conceptual clarity you got, design awareness principles, very important, like the modular architecture, the scalability aspect, all that we learned, the resilience, future proofing, and strategic maturity it was able to give us. So we can summarize the module 1 in 3 layers. So if we talk about module 1 summary in 3 layers, so we had, like, layer 1 is the intelligence layer. Okay, so if I talk about agent, agent has got intelligence, and foundation models are responsible for it, the reasoning power, the planning power. Then the layer 2 of agents is the agency, wherein agents, they can not only just respond, they can act. So we saw that, okay, agent, they should have goal, tools, memory, that is the context, planning, and autonomy. Autonomy means agent knows that, okay, this is the goal I want to accomplish. It will on its own make the plan without human intervention. That's the autonomy. And layer 3 is the system design. This is also very important, wherein once the agent is ready, we have to consider the aspects of scalability, modularity, reliability, security, very important, governance, production readiness. So the key takeaway from this module is, see, after module 1, we haven't built any system. We have not yet built any system. We have built understanding. So in subsequent models, we will be building something interesting. But module 1 was all about understanding. And that is what we were able to do. So finally, we completed this lecture and the module 1 of the course. I hope you got a very good understanding of the concepts which we covered in this lecture and also in the module 1. So do subscribe to our YouTube channel, ScaleUp University, for more such interesting lectures and courses. Thanks for watching. Thanks for your time.